All right, let's look at some more context here. So, museum purchases a painting and a sculpture in the same year. Um, the information for the sculpture is given as a function. The information for the painting is given as a chart, as a graph. So we're going to compare them and answer the question of which artwork's value is increasing more quickly um, over a 5-year period. So if I look at the function, the original starting value was 50, right? Let's figure out how much the sculpture was worth after 5 years. So we're simply going to take the function, substitute 5 in, right? And you get 71.78. If I get the average rate of change over those 5 years, you take the amount of change, which is 2178, divided by 5, right? Because there's 5 years. So then the average rate of change, the amount that it's gone up um, over the 5-year period, is $4,356 per year. Looking at the graph, you just pick 2 points off. Your starting value was $40,000. After 5 years, it's now worth $64,400. Find the average rate of change with those, and you get that it's $4,880 per year increased value. So that means the painting is increasing value more quickly than the sculpture. So even though the sculpture is worth more, the painting is increasing faster. So then the you try it question is simply, will the painting's value ever catch up to the sculpture's value? So since the sculpture was worth more to start with, the painting has to be increasing more quickly in order for the painting to catch up. So it is. So since we already calculated that it is, it will eventually catch up. It's very similar to like a distance rate time question where someone starts walking an hour before someone starts running. The person that's running that's going faster will eventually catch up to the person that's walking, assuming they're going in the same direction, right? That's exactly what's happening here. The value of the painting is going to catch up to the value of the sculpture because the value of the painting is increasing more quickly. Algebraically, we could calculate when that exact moment would happen. We're not there yet. That's something that we're going to be taking with this, taking this content, a direction we're taking this content eventually. So just keep in mind that's a question we will eventually be able to answer. Algebraically, not quite. So at this point, I want you to start practice on the 6.1 practice. Let me know if you have any questions. Otherwise,